Learning target 9 is about, we're going to start graphing sine and cosine functions. And that's not going to go away. So today we're just going to do sine functions, talk about cosine functions tomorrow. All right? But we're going to really nail down sine and cosine because then in learning targets 10 and 11, we're going to start doing some things to those functions, and we'll have a quiz. And then after that, it still doesn't go away because we're going to be doing more stuff to sine and cosine functions. And then to graph secant and cosecant functions, you know how to graph sine and cosine functions. So they're not going away. So to make sure we know how to do this, all right? It's all based on your unit circle. That's why I said you need to do your unit circle today. Okay, so I'm not like making up where this is coming from. It all comes straight from the unit circle. Okay, so first thing though is learning target 8. We're going to talk about periodic functions. So sine and cosine functions are periodic functions. And that means that the values of a function are the same for each given interval of the domain. So all that means is a super fancy way of saying that the y values of the function repeat over and over again. So a periodic function is just a function that repeats. The period of the function then is the interval, or how often the function repeats. Does it repeat every 3 units? Does it repeat every 7 units? Does it repeat every 10 units, etc.? Okay. So periodic function is just one that repeats over and over, and the period is how often it happens. So learning target 8, here's 2 examples. We're going to determine if the function is periodic, and if it is periodic, we're going to give the period. So this first one up here. Does the function repeat over and over again? Yes, so it is periodic. We need to figure out how often it repeats then. So how often does this function repeat?
Every 2 units.
The entire function is repeated every 2 units. That's only the top peak. Every 4 units, right? So we have to include the entire cycle of the function, right? So this period is 4 units because we have to include the top and the bottom, right? So every 4, that little section is repeating over and over again. That makes sense. All right, on the bottom one, is the bottom one repeating over and over? No. It has a pattern, but the y values are not repeating over and over. They're different y values each time. Okay? So that's not periodic. That's just a step function. If it was periodic, it would, like if we ignored all of these up here, if it was periodic, then it would look like this. Or the same y values we're repeating each time. Okay? Questions about periodic functions? So that's all learning target 8 is. Learning target 8 is the easy one today, right? We're just saying, yes, it's periodic. No, it's not. Some of the homework problems aren't pictures. They just give you equations. For example, if I just wrote the equation y equals x, what kind of graph does that make? A straight line, right? Does a straight line repeat? No, so it's not periodic. So they're not trying to be confusing, but some of the homework questions just give you a function. If you're not sure what it looks like, you can always graph it, right? But again, to be periodic, that function has to repeat over and over and over again. Okay. So learning target 9 is graphing sine and cosine functions. I'm only going to graph the sine curve today. You have 2 options. You can do this with me, or you could just watch, because I'm going to talk about this in depth, and so you could just watch what I'm doing to make sure you understand where it's coming from. All right, that might be smarter. Okay. The first time I graph this, I'm going to graph it in a lot of detail so that you know where I'm getting the curve from. Okay. After that, I will never graph it in that much detail ever again, and neither will you. But I just want you to see it one time, so that way you know I'm not making up numbers. Okay. All right. In a graph of a trigonometric function, so in this sine curve, the x-axis is radian measures. Okay? The radian measures that I'm going to use are the radian measures on the unit circle. Okay? So when I start doing my scale in a second, then I'm going to start at 0, And I'm going to be using all of these radian measures on the x-axis. Okay, so that's what I'm doing. I'll write the first few, but then I'm going to stop writing them so I can just go like every 4. So we've got 0, pi over 6, pi over 4, pi over 3, pi over 2. Then you would have 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. Then we would have 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Right? You could go backwards as well. If I went backwards around the unit circle, I would start at 0. This would not be 11 pi over 6, and this would be negative pi over 6, and then negative pi over 4, right? Going backwards, just like we did before. This was positive 30, and this was negative 30, right? Same thing. Okay, so I could go backwards as well. Could happen. All right. The y values then of the function are the sine values on the unit circle. So you've talked about several times that the sine values are the y part of the coordinate. So if I'm going to graph whatever, if I'm going to start at 0, the sine at 0 is 0. So that's what I'm going to graph here. At pi over 6, sine is 1/2. So that's what I'm going to graph. Okay, I'm not going to keep going back and forth. But that's where I'm getting these numbers from. If you look at the unit circle, the largest sine can get is 1. All right, so pi over 6 is at 1/2. Then at pi over 4, you're at the square root of 2 over 2, which is a little bit more than 1/2. And at pi over 3, you're at the square root of 3 over 2, which is a little bit more than that. And at pi over 2, I hit 1. Any questions so far about where those 4 points have come from? Got it straight from the unit circle, right? The radian measure and then the sine value that corresponds to that. So then I would keep going. At 2 pi over 3, we have square root of 3 over 2. And at 3 pi over 4, the square root of 2 over 2. And at 5 pi over 6, you're back at 1/2. And at pi, you hit back at 0. Right, I'm getting those values straight from the unit circle. You keep going. Then at 7 pi over 6, you're at negative 1/2. And then negative square root of 2 over 2. And negative square root of 3 over 2. And negative 1. And then you keep going, and you have negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and 0. Okay? Then if I hit 0, and if you keep going, if you go around the circle again, right? So if I don't have to stop at 2 pi, I could go all the way around, and then I could go again, right? Then all of those values I just graphed are going to repeat again, right? So that's why this function is periodic, because it's going to keep going over and over. So I draw this in. That's my sine curve. It's a wave, okay? Notice that it is not peaks. It's not pointy and straight. It is a wave, okay? So some things you need to realize about this to make your life easier today, okay? If it asks you about the period of a sine curve, this is going to repeat every 2 pi, right? One revolution around the unit circle is 2 pi, and that's what we did to graph this section. So if we keep going around the unit circle, we're going to keep hitting the same values, right? So this really will look like this if you kept going, okay? All right. What's the maximum value the sine curve can be? 1, and the minimum is, so then what is the range? -1 to 1, right? Side note, on the pretest, there was a question just like this, okay? So you had a picture of a curve, and it said, what's the range? And you guys all identified. You're like, oh, it goes from -1 to 1. It wasn't a problem. The problem was you didn't pay attention to detail. So there were 4 choices, right? some of them were like from a half to negative 1/2. You knew that wasn't right. But there was 2 choices, then you could have eliminated and could have got it down to 2. One choice was this, and one choice was this. And the one with the X came first. And so since you were just kind of like glancing at it, a lot of you guys could put the one with the X in it. X doesn't account for range values, right? X counts for domain values. So I know you know what you're doing. I got it. But just make sure you're looking at all the choices, right? You're going to see that question again someday, and I don't want you to miss it again because you put X for the range, okay? All right, what's the domain of this function? This one's going to be all real numbers, right? I can use any radian value I want to. I don't have to use one on the unit circle. It's just the easiest way to illustrate where this is coming from. Right, I can use a radian value of 3. It's not on the unit circle, but I can use it. Okay? All right. Now, some other things that'll make this easy for you today. Where are the x-intercepts? Where are the x-intercepts? Right now there's one at 0, one at pi, and one at 2 pi. So if we kept going, we'd have one at 3 pi, and 4 pi, and 5 pi, and 6 pi. So the x-intercepts are all at pi times n, where n is an integer. Because they all have pi in them, right? Radian has pi in it every single time, right? So it's just the integer values of pi. So -1 pi, -2 pi, and 5 pi. Just not the fraction ones, okay? That'll make your life immensely easier today if you know that there's an x-intercept there every single time. Now, I said that generally I'm not going to graph this in this much detail, okay? Generally, when I graph this, now that I know what it looks like, all these points in between the maximum and the minimum and the x-intercepts are completely irrelevant to me when I'm graphing this. I know that it makes a curve, but it's easier just to graph the x-intercepts and then the ones and the negative ones instead of all the stuff in between. It gets way complicated, especially when we start shifting things around and everything. It's easier to graph the maximum and the minimum and where the x-intercepts are. All right? So if you asked me on any other day to graph this, I would have done the following. I would have 0, pi over 2, pi, 3 pi over 2, 2 pi, and that's what I would have graphed you. You would need to get to the point that you're going to graph that too. You don't need to graph everything else in between. It's just going to make your life more confusing. Okay? You want to graph the x-intercepts, the maximum minimum values, and know that it curves in between. Okay? It'll make tonight's homework a lot easier. All right. Questions about why I did that? The maximum minimum values and the x-intercepts only occur at the 4 directions, like the cardinal directions of the unit circle. Right? That's where the x-intercepts and your max and min values are. Okay? So that's why I'm graphing those at pi, pi over 2, that kind of thing. Now, here's why the homework is confusing. It's not that part, I think you guys all got where I got the sine curve from. You could graph that again if it's not a big deal. But to get you to practice, I have you graph it on different intervals. So instead of graphing it from 0 to 2 pi, I have you graph it elsewhere. All right? It's the same curve, just making you graph it different places. So it's going to take a good looking at the unit circle and some things to make sure you can graph it. If you can count by a half, then you're in good shape. All right? So if the interval is positive, so you're graphing it from like 3 pi to 5 pi. All right? Well, if you're graphing it from 3 pi to 5 pi, I'm going to graph, again, just the pi's of the integers and then the halves in between. Okay? So 3 pi, I need to understand what that is as a fraction, like a half. 3 pi is the same thing as 6 pi over 2. Does that make sense to everyone? Right? Yeah? So 3 pi on the unit circle, here's 0, here's pi, here's 2 pi. So 3 pi would be right here. Right? And I would need to continue and hit this point And then this point, that'd be 4 pi. And then this point, and then this point to get back to 5 pi. That's what I was graphing the interval, 3 pi to 5 pi, right? I need to know what's in between. So if I know that 3 pi is 6 pi over 2, then each quarter of the unit circle is just pi over 2. So if this is 6 pi over 2, then here is 7 pi over 2. Does that make sense? Another pi over 2 would be 8 pi over 2. And then 9 pi over 2. And then 10 pi over 2. I'm going to be doing a lot of counting today by pi over 2. All right, I'm going to do an example, so don't freak out. But I'm going to do a lot of counting today by pi over 2. And that's what I'm getting from every quarter is pi over 2. All right? So let's do an example together where we're graphing this on a different interval. So on your note sheet, it says to graph this from negative 4 pi to negative 6 pi. So we're going to go from negative 4 pi to negative 6 pi. Again, I want to hit the pi's and the halves in between. Okay? So if I was going to write negative 4 pi, instead of a fraction, that was a fraction of a half. So negative 4 pi is also what? Negative what over 2? Negative 8 pi over 2. That's what I'm keeping in mind the entire time because I'm counting by a half each time. Okay? What did I get what? I need to be able to count by quarters on the unit circle, so I need to be able to count by pi over 2, because each quarter on the unit circle is pi over 2. Okay? Each quarter. Like this, it starts at 0, it goes by pi over 2, right? And then another pi over 2 would be 2 pi over 2, right? Okay? And those are the points I want to graph, are these 4 points each time. So I need to be able to put everything into halves so I can be able to count around the unit circle. So on this problem we're doing right now, on the note sheet it says we're going to graph from negative 6 pi to negative 4 pi, right? So really it's going from negative 4 pi to negative 6 pi logically. Right? Okay. I need to have negative 4 pi as a fraction. So negative 8 pi over 2 is the same thing as negative 4 pi. That's how I got that. I just doubled 4 and divided by 2. Help a little bit, but where I got that from? We'll do some more. It'll be okay. So my next hash mark then will be negative 9 pi over 2. Right? Because we have negative 8 pi over 2 to negative 9 pi over 2. So the next one would be negative 10 pi over 2. Well, negative 10 pi over 2 reduces down to negative 5 pi. And the next one would be negative 11 pi over 2. And the next would be negative 12 pi over 2, which is negative 6 pi. That's the interval I'm supposed to graph. Yes? Maybe. All right, we already talked about that we know where all of the x-intercepts are. For the sine curve, the x-intercepts are all the pi's with an integer. So there are 3 on this interval. One at negative 4 pi, one at negative 5 pi, one at negative 6 pi. Right? The x-intercepts are always at those pi pieces with the integer. Okay. So the only thing left I need to do is I need to figure out where we're at 1 and where we're at negative 1. All right? Because from negative 6 pi to negative 4 pi is a full period, right? It's 2 pi. So I just need to know where we're going up and where we're going down. I can use the unit circle to do that. So I'm just going to do that. I'm going to use the unit circle. I'm going to count. So I need to figure out what is happening at negative 9 pi over 2. Yeah? So we're going to start at 0, and we're just going to count and keep going. So if we're going negative, that means we're going this direction. Yes? Agreed? And again, each quarter is pi over 2. Yes? All right, so I'm going to start counting. So if I start at 0, and I go this direction, then this would be negative 1 pi over 2. And this would be negative 2 pi over 2. I keep going around, this would be negative 3 pi over 2. I keep going, this would be negative 4 pi over 2. I'm going to keep going, so this is also negative 5 pi over 2. Around, this is also negative 6 pi over 2. At the top, we're at negative 7 pi over 2, right? And I keep going, we're at negative 8 pi over 2. When we go around again, we get negative 9 pi over 2. So, negative 9 pi over 2 is at the bottom. Everyone know how I got to negative 9 pi over 2? Okay, so what is sine at negative 9 pi over 2? Negative 1. So, I'm going to put the negative 1 down here, right? And if I kept counting, then this would be negative 10 pi over 2, and this would be negative 11 pi over 2. So that was my other place, and sine is 1 at negative 11 pi over 2. Yes, maybe, possibly. That's what I was looking to graph. That's my sine curve on that interval. It always looks the same. There's x-intercepts at all the pi's with integers, and then at all the halves, there's a 1 or a negative 1. Right? This can be difficult, and I get it. Because you have to figure out the interval. You have to kind of think differently, because it's not straight off of the unit circle. You have to kind of convert everything. Right? But it's just a lot of counting. A lot of counting. Do you want to try some? See how it goes. Do you want me to do another one? Is me doing another one going to help, or I just want to try some? Let's just try some. So let's just, how about we just try some, and I'll just be around the room to assist. Okay, so here's what we're going to do. Listen very carefully. You're going to do Learning Target 8 homework, because that's just the is it periodic or not. That's not a problem. On Learning Target 9, so you have to listen. Learning Target 9 is graphing sine and cosine curves. We have not talked about cosine curves today. You could probably figure it out, but we just haven't done it today. All right? I'd rather just focus on one thing at a time. Okay? Now, the first part of Learning Target 9 just says use the graph to find each value. So the first part is going to say, like, for example, what is sine of 9 pi? You're not graphing it. You're going to use your unit circle to figure out what the sine of 9 pi is. That's really all it's asking you to do. Okay, so you're going to count around to get to 9 pi, and you're going to tell me what sine is. The second part is where you're actually going to graph. And you can only graph the ones that say sine, because we haven't talked about cosine. So there's 6 graphs. You're only doing 3 of them, because 3 of them talk about sine. Okay? I want you to try it. I'll be around here to help. And if you are confused tomorrow, that's okay. We'll talk about it some more. Okay?